all students are welcome to next chemistry lecture. Here today we are going to discuss next unit, chemical kinetics. Particularly chemical kinetics, it comes under physical chemistry, the branch of chemistry, physical chemistry. So what are the points to be studied in this unit? And then we see all the points one by one. So starting with the points covered under this unit. So chemical kinetics, particularly first we see concept of chemical kinetics or simply definition of chemical kinetics. Then rate of reaction, definition of rate of reaction. Then its types. First one, average rate of reaction, simply how average rate of given chemical reaction is calculated or expression for average rate of reaction. Second type, instantaneous rate, definition, its expression and examples based on these two types. Next point is rate of reaction and concentration. Here in this point, rate law, how rate law is written, and then order of reaction, first order, second order, then pseudo order and zero order reactions and some expression for it. Then next point, molecularity of elementary reactions. So definition of molecularity of reaction, elementary reactions, then order and molecularity, the difference between these 2 points, order and molecularity of reaction. Now next point is integrated rate law. How integrated rate law is applicable or it is used for first order reaction. Then next point, half-life of first order reaction, half-life and rate constant for first order reaction or expression for half-life and rate constant for first order reaction. Then zero order reaction, same, half-life, then half-life and rate constant expressions, same. Then last one, pseudo order reaction. And last point, how catalyst plays an important role in the rate of reaction or effect of catalyst on the rate of reaction. These are the points which are covered under the unit chemical kinetics. So students, here we first see what is chemical kinetics. So chemical kinetics comes under the branch of physical chemistry of simply chemistry. So chemical kinetics definition, chemical kinetics is a branch of chemistry which deals with the particular rate of chemical reactions and the factors those affect them. It is the standard definition for chemical kinetics. So what is the rate of reaction? Simply, if we consider any reaction A plus B, it gives C plus D. Here A and B are reactants on the left side and C and D are product formed. So as we mix two different chemicals or reaction proceeds, the reactants gets consumed during chemical reactions as time goes on, and simultaneously there is a formation of product C and D depending on the different conditions of reactant. So what is the rate of reaction? Simply rate of reaction is how much amount of reactant is consumed during chemical reaction and how much amount of products are formed during chemical reaction per unit time. It is simply termed as rate of reactions, and this rate of reaction is simply depend on or some factors affects on this chemical reaction, that the conditions of that chemical reaction. Conditions are temperature, pressure, catalyst, in concentration of reactants, etc. So this is the constituent or simply concept of chemical kinetics. So one by one we see different points comes under this unit, chemical kinetics. So first one is a rate of reactions. As previous, we see what is the rate of reaction and what are the factors affecting the rate of reaction. So start with first point, rate of reaction. The rate of reaction describes how rapidly the reactants are consumed or the products are formed. As we seen previously, rate of reaction, as the reaction goes on, A plus B reacts with each other at different conditions of temperature, pressure, concentration, catalyst, etc., and there is a formation of C and D product. So reactants gets consumed and there is a formation of products. This term under this is called as rate of reactions. So there are two important types. First one, average rate of chemical reaction, and second one, instantaneous rate of chemical reaction. So first we see definition of average rate, then expression for average rate or how average rate of given chemical reaction is calculated, then instantaneous rate, simply definition and how it is calculated, or expression for average rate, and simply one example on this one. So starting with average rate of chemical reaction. So the average rate of reaction can be described by knowing change in concentration of reactant or product divided by time interval over which the change occurs. We consider an example, A plus B, it gives C plus D. As the reaction start, A plus B reacts with each other, and as time goes on, there is a formation of, simultaneously there is a formation of C and D. So average rate of reaction, simply it is change in concentration of species divided by the time interval through which these changes goes on as time increases. What are changes? Here changes are simply consumption of reactants A and B, and there is a formation of product C and D, and this change in concentration per unit time or through the time interval through which the changes takes place is termed as simply average rate of chemical reaction. So how average rate is calculated? Simply formula, see it is on your screen. Average rate is equal to change in concentration of species divided by change in time. Change in concentration of species, here species, reaction constituent, simply A, B and C and D. A, B reactants on the left hand side, C and D products which are formed on the, or it is represented on the right side of the chemical reaction. As we move or as time goes on, there is a consumption of reactant takes place and simultaneously there is a formation of product C and D. So it is equal to delta C by delta T. Delta C, the change in concentration of species. This is the Greek symbol delta, and C, change in concentration of species, reactants and product, and delta T, it is a change in time or per unit time or the time interval through which these changes takes place. Now in your book we see example in your book. Simply consider a reaction. A gives B. Here A is a reactant, B is product form, in which A is consumed and there is a formation of product B. So first we see how the consumption of A takes place. So first average rate of consumption of A is equal to minus delta A upon delta T. Here delta A, the A given in bracket, it is represents the concentration of A, and by delta T. Second, average rate of formation or production of B is equal to plus delta B upon delta T. Here signs are important. First we, while writing of average rate of consumption of A, there is a given negative sign, and while writing of average rate of formation of B, there is given positive sign. So what are the meaning of these signs? We see after this one. So we have to calculate average rate of reaction total is equal to minus delta A upon delta T is equal to plus delta B upon delta T. So what is negative sign indicates here? Negative sign indicates that there is a decrease in concentration of reactant per unit time. As time goes on, there is a consumption of reactant sites, that is A1 or 2 reactants. So there is a decrease in concentration. So we take here the negative sign. Here meaning of negative sign is not that the concentration is or the values of concentration are in negative, but it is sign only for decrease in concentration of the reactant per unit time. And second positive signs in shows the increase in concentration of product per unit time. As the reaction goes on or as time passes, there is a formation of product, that the concentration of product side goes on increasing. These are the meaning of these minus and plus signs. And last one, the dimensions or units of rate of reaction, that is it is given by concentration divided by time, that is mole per cubic decimeter per second square, or mole into dm raised to minus 3 second raised to minus 1. So simply student, this is the concept of average rate. Now next, instantaneous rate of given chemical reaction. Next one. So what is the instantaneous rate? The rate of chemical reaction at a particular instant, or the time interval or small time interval through which we measured this rate of given chemical reaction. Particularly say it is instantaneous rate or at a specific time. So how it is calculated? Same as average rate. Again consider a reaction A gives B. So rate of first we have to write the rate of consumption of A at any time t is equal to minus d concentration of A upon dt. Second, rate of formation of B at any time t is equal to plus d concentration of B upon dt. Here printing mistakes takes place in your book, so correct it. Then total rate of reaction at time t is equal to minus dA by dt is equal to dB by dt. Here small d sign is used here. Triangle like side delta, triangle like side is a capital form and small d is in small letter types. So here the concentration are small, that is at a specific time. While writing the average rate, we cannot consider the rate at particular time or at specific time, but here while we considering the instantaneous rate, we consider the rate of given chemical reaction at a specific time. So here we write rate of consumption of A at any time t or rate of formation of B at any time t, and it is given by minus dA by dt is equal to plus dB by dt. So while we are observing this one, here reaction considered A plus A, it gives B. Here 1 mole of A and 1 mole of B. The rate of consumption of A equals the rate of formation of B, while there are 1 mole on reactant side and product side. So this equation or this expression is not applicable if there are number of moles are different on reactant side and product side, or stoichiometry are different. So see in your book, we consider a reaction A plus 3B, it gives twice C. So here number of moles of A equal to 1, here number of moles B equal to 3, and there is a formation of 2 moles of C. So above equation is not applicable for this. So how? Here the stoichiometric coefficients of the three species are different. Here if you observe the given chemical reaction, here the rate of consumption of B is 3 times the rate of consumption of A. While there is a reaction goes on or as time passes, there is reaction takes place between A and B, and consumption of A there is 1 mole of consumption of B. During this time there is consumption of 3 moles of B, so it is 3 times the rate of consumption of B is 3 times the rate of consumption of B. Also, if you observe the reaction, the rate of formation of C is twice the rate of consumption of H of A. Now, by this chemical equation, we can write the instantaneous rate. So, first on reactant side, minus dB by dt is equal to minus 3 dA by dt. That is, it is the rate of consumption of B is 3 times the rate of consumption of A. So we can multiply the rate of consumption of A by 3. It is 3 times. Then second equation, the constant change in concentration or at instant time dC by dt is equal to minus twice dA by dt. The rate of formation of C is twice the rate of consumption of A. As we rearrange this equation, first equation minus dB by dt is equal to minus 3 dA by dt. We shift the 3 on the left side equation, so it becomes minus 1 by 3 dB by dt is equal to minus dA by dt. And second, also in second equation we shift 2 on left side of this equation. This becomes 1/2 dC by dt is equal to minus dA by dt. As we observe these two equations, that is their right sides, that is minus dA by dt are same for both equations. So right sides are equal, left sides are equal. So from above equation we can write the overall equation is equal to minus dA by dt is equal to minus 1 by 3 dB by dt is equal to 1/2 dC by dt. Or rate of reaction is equal to minus dA by dt is equal to minus 1 by 3 dB by dt is equal to 1/2 dC by dt. This is the instantaneous rate. Or in general, if we consider reaction AA plus BB, it gives CC plus DT. What is AA? Small a, small b, small c, small d represent the number of moles of that particular species. That is, small a represents the number of moles of A, small b represents number of moles B and C, C and D. And capitals are shown the reactants A, B, C and D. And how we write instantaneous rate is equal to minus 1 upon A dA by dt is equal to minus 1 upon B dB by dt is equal to 1 upon C dC by dt is equal to 1 upon D dt by dt. That is, here first we consider the sign. If it is on reactant side, then write first negative sign. If it is on right side, that is product side, write positive sign. Then write the number of moles, or it is divided by number of moles. First 1 upon A, in second 1 upon B, 1 upon C, 1 upon D, and then write the change in concentration per unit time of that particular species. That is, rate is equal to minus 1 upon A dA by dt is equal to minus 1 upon B dB by dt is equal to 1 upon C dC by dt is equal to 1 upon D by dt. So this is the concept of instantaneous rate. So students, see example. What is the given example? Problem number 6.1. Here the reaction is given: 2 moles of N2O5 gas. It gives 4 moles of NO2 gas and plus 1 mole of O2 gas in liquid bromine. Here change in concentration per unit time or disappearance of N2O5 is given by at a rate of 0.02 moles per cubic decimeter per second square, and we have to calculate the rate of formation of NO2 and O2 and total rate of reaction. So students, carefully listen. Here in your book, the problem number 6.1, there are some printing mistakes. So please refer the problem I will solve on this paper, and it is shown on your screen. So write down the problem clearly from your screen while you seeing this video. So how it is calculated? First we solution for this problem. Here concentration of N2O5 dN2O5 by dt is equal to 0.02 moles per cubic decimeter per second square. Here rate of consumption of N2O5 is given, or disappearance. So how rate of reaction is written is equal to minus 1 half dN2O5 by dt is equal to dO2 by dt is equal to 1 by 4 dNO2 by dt. So rate of formation of O2, how it is calculated? dO2 by dt is equal to minus 1 half dN2O5 by dt, that is minus 1 half, and concentration of disappearance of N2O5 is 0.02. There is a minus, we have to write the negative sign. So minus minus positive, and the calculation or result is answer is 0.01 moles per cubic decimeter per second square, that is rate of formation of O2, same as rate of formation of PnO2. This equation 1 by 4 according to instantaneous rate of equation 1 by 4 dNO2 by dt is equal to minus 1 half dN2O5 by dt. It is put the values minus 4 upon 2 you have to shift to the 4 on right side. So 4 upon 2 into bracket minus 0.02. So minus minus plus, solve this one, we get the final answer 0.04 moles per cubic decimeter per second square. So carefully you have to write the example from your screen. There are some printing mistakes in your book. So students, in this lecture we start the new unit, chemical kinetics of physical chemistry branch, and see what is the definition of chemical kinetics, then average rate of reaction, how it is calculated, second instantaneous rate definition and how it is calculated, and example based on these two. So thanks a lot all students for joining this lecture.